another video. In today's video, I'm going to provide a solution to this problem. Solution. Now we are given square root of m plus square root of n, okay, equals to 108. So m and n are all positive integers. So m is greater than 0 and n is also greater than 0. So we have these conditions here. Okay, now from here we can write this as square root of m plus square root of n equals, now let's write this one, 108, as 36 times 3, 36 times 3 is 108. We are using 36 because this is a perfect square. So we have square root of m plus square root of n equals, so this side will be square root of 36 times square root of 3. Now from here you can say square root of m plus square root of n equals, so 6, 3. Alright, now let's observe something here. Now I want to do something with this, so we should let the m here, let m here be this 3 times a variable squared, another variable, so let's make it x squared, and then this n will be the same 3 times another variable squared, so let's make it y squared. So from here we can do substitution. Alright, so square root of m will be square root of 3x squared plus square root of 3y squared equals to, let me check, 6, 3. Alright, now from here we can write this one as square root of x squared times square root of 3 plus square root of y squared times square root of 3 equals to 6, 3. Now from here this square will cancel this. I will leave with x with 3 plus, so this one will cancel, y with 3 equals to 6, 3. Now from here we can get rid of the root 3, so we can divide through. So this side will cancel, this side will cancel, this side will cancel. I will have with x plus y equals to 6. Now let's observe this. So from here x, y. Now if I put 2 here, this side will be 4, and if this side is 4, this side will be 2. If this side is 5, this side will be 1, and this side is 1, this side will be 5. So we have 2, 4, or 4, 2, 5, 1. Let me make it 3, 3, 4, then 5, 5, 1, then 1, 5. So let's recall from here m and then n, then let's see the way forward. So let's start with 2, 4. When x is 2 and y, we have m equals to 3x squared. We have m 3x squared and n 3y squared. So let's start with 2 4 xy. Okay, the first pair 2 4 2 4. So 2 4. Now from here, if x is 2, okay, this is x, this is y, so m will be, so 3 times 2 squared, that will be 4 3 12. Then n will be, so 4, we have 4 4 4 16. Okay, you have 3 times 4 squared. Okay, so this one will be 16 times 3, that will be 48. So we have the first pair as m equals to 12, n equals to 48. So let's keep this one here. Now remember that addition is commutative here. So if this side is 2 4 and we have 4 2, it means the answers also change. So from here, xy, so if it is 4 2, it will affect this one. So my m will be 48 and my n will be 12. So we are done with the first two. So let's go to when x is 3. So when x, so the next pair 3 3. So my m will be 3. So 3 squared 9, 9 3 27. So let me write the answer straightforward. My n will also be 27. So that's that. Now let's go to 5 1. That will be the last. So xy 5 1. Okay, so my m is 3x squared, 3y squared. So when m is 5, this side will be 25. 5 squared 25 times 3. That will be m is equal to 75. And this side will be 3. N will be 3. And if I interchange the position, that will be when x is 1 and y is 5. That will make this side m equals to 3 and n equals to 75. Okay. Now we have the first answer as 12 and 48. So let's verify the first answer and see if it will satisfy the equation here. Okay, so square root of m, square root of n, we have 108. So let's verify. Square root of m plus square root of n equals to square root of 108. So let's choose the first pair. Okay, let's verify the first pair. So 2 4 has given us 12 48. M is 12, n is 48. M is 12, n is 48. Okay, so from here we have square root of 12 plus square root of 48 equals to square root of 108. So let's verify if we'll get both sides equal. So this side will be 4 times 3 and this side will be 16 times 3 equals to 36 times 3. So this side will be 2, 3. So for this one is perfect square. This side will be 4 with 3. And this side will be 6 with 3. So 2 plus 4 is 6. 6 with 3 equals to 6. Okay, so hence proved. Okay.